Welcome back to Cypress Academy, PSoC 6 101. In the last lesson, I showed you how to build a BLE peripheral with a custom service for an LED dimmer. In this lesson, I think that I'll add BLE to the MainController project and modify it from LED dimming to motor control. First, let's add the BLE component to the schematic from our MainController project. Then configure it for peripheral, one connection, and dual core. Once that's done, I want to create a motor service. Well, actually, I already did that for you. So, from the GATT settings tab, right-click on the server and select Add Service from File. Pick out the motor service file and hit Go. PSoC Creator will load the configuration I created. When you look at it, you'll see a custom service called motor. The motor service will have 4 characteristics, 2 of which we will use to set the position of the motor, and 2 of which that we'll use to make relative position changes. The M1 and M2 characteristics are uint 8, and they're configured for read, write, and notify. The M1 rel and M2 rel are write only. Notice the M1 and M2 characteristics each have a characteristic user description as well as a client characteristic configuration, also known as a CCCD. These are related to notifications, which is something new that I'll tell you more about in a later video. Now let's set up the gap settings. Give this beast a name. How about PSoC 6 Robot? On the advertising settings, set the discovery mode to general and no timeout on the fast interval. Then in the advertising packet, let's advertise the local name and the motor service UUID. This will let our remote control find us, and I'll tell you more about that in a future video. I told you in the previous videos, I like to use LED 9 to show that there's an active connection. So we'll add a digital pin called LED 9. With no hardware connection and initialized to high. Then in the DWR, I need to assign it to P13.7. Next, run generate application to pull in all of the BLE middleware and let PSoC Creator get everything all connected up for us. First, we need to make the max 6 call interrupt priority change in free RTOS config.h, just like in the previous project. Remember from the previous video, we want to run the controller portion of the BLE in the CM0+. So edit the main_cm0p.c, start the BLE, then process events in the main loop. Now I will create BLE Task.h. It will have a pragma once and a definition of the BLE task. Onto the main_cm4.c. I'll add the include for BLE Task.h and then start up the BLE task. And last, but not least, I need to actually do the BLE work by creating BLE Task.c. This task is going to be a lot like the simple BLE peripheral BLE task. So I think I'll just start by copying from that project. I will copy from the top all the way to just before the main function. At the top, I'll include global.h. Now we need to make some changes to the BLE Event Handler. First, instead of just blinking the LED, we're just using LED 9. So there's no connection, and then it'll be off. And when there is a connection, it will be on. So let's see here, CY GPIO_write LED 9, yeah, okay. Now let's delete the TCPWM stuff, and when there's a connection, turn on LED 9. Now the write request stuff is going to have to be redone. But for now, I'm going to put an if 0 and an end if and see if it will start advertising and if we can connect. Obviously, we won't be able to write the characteristic, but that's okay. It's a good place to start. So I hit program and let it rip. We will use the Android version of CY Smart this time so you can see what it looks like. When I start up CY Smart, I see that there's a peripheral called PSoC 6 Robot. It's advertising, that's good, and when I connect, LED 9 turns on. I can then open the GATT browser and I'll see and select the custom service. I can see that there's 4 available, which is what it should be based on our service configuration. All right, now back to the BLE Task.c. First, let's add an include for the PWM task so that I can send it messages. Next, I want to make a function called update motor GATT that will be responsible for actually writing the values into the GATT database, meaning changing the characteristics for the motors. There's 2 possibilities for changing the position of the motors. It could happen locally because the user touched the capsense or typed on the UART, or it could be getting a command from the BLE Central that's attached. Either way, the GATT database needs to be kept up to date. The reason that the GATT database needs to be kept up to date is because the remote control end wants to be able to read the current position of the motors. So let's build this function that can make updates to the GATT database that are initiated locally, for instance, by the PWM task, or remotely from the BLE Central. This function takes a motor, remember M1 or M2 from before, a value, and a mysterious flag. Actually, the flag will tell the system if it's a local write, meaning the motors change positions locally, or a write from the BLE Central side. When you call CYBLE GATT write attribute function, you need to give it a pointer to the CYSTC BLE GATT handle value pair. So I'll declare one of those beasts. Then I'll error check the % to make sure it's in range. Then figure out what the handle is of the characteristic we're talking about, either M1 or M2. Once that's done, I'll figure out if it's a local or a remote write. If it's from the peer or the BLE Central side, I'll first write it into the GATT database. Then I want to send a message to the PWM that the value of the motor has changed. So I'll build up that message and I'll send it. If it's a local write, then I just need to write into the database. Now remember earlier I told you about the CCCD. Well, here's where it comes into play. It's possible for the central side to be notified if the value of a characteristic changes. And remember that we set up M1 and M2 with this notify capability. The CCCD characteristic is where the GATT database keeps track of whether or not the central wants to be notified for a particular characteristic. So after we write the attribute to the database, we need to call the CYBLE GATTSS notification function, which will figure out if they've asked for notification and then send the notification if they have. Remember, I used #if to exclude a section of the BLE Event Handler. Let's go back and put it in. When you get a CYBLE Event GATT write event, there are 6 possibilities. The central wrote an M1 or an M2, the central wrote an M1 relative or an M2 relative, or lastly, the central changed whether or not it wants to be notified of changes to the M1 or M2 characteristics. In other words, the CCCD. So let's deal with these 6 possibilities. If it's a write to M1, then we will use the handy dandy helper function update motors GATT. Then we'll do the same thing for M2. If the central asked for a relative change in M1, then let's make a PWM message that requests a relative change and send it. And what do you know? It's the same thing for M2 relative. And finally, if the BLE Central changes the CCD of M1 or M2, then let's make one of these crazy CY, STC, BLE, GATT, DB attribute value pairs and fill it out with the connection and value, and then write it into the database using the function CY BLE GATT write attribute. That's it. Oh, hang on. For all of these cases, we need to send a write response, so we'll call CY BLE GATT write response. Now that we've fixed up the BLE Event Handler, you need to make one little change to the event loop. Specifically, after you've been woken up, you should check to see if the PWM values changed locally, which you can tell by using the event bits. And if the values have changed, then you should update those values of M1 and M2. All right, hit program and let's try this thing out. I'll start up CY Smart again, connect to the robot, open the GATT database browser, and select the custom service. We still have our 4 attributes available. The first 2, M1 and M2, are read, write, and notify, and the last 2, M1 rel and M2 rel, are write only. And this makes sense because, that's how we defined it. The phone wants to be able to read the current position of the motors from the first 2 characteristics, but reading a relative position of the motors is mostly meaningless. Let's select the first characteristic, which is M1, and read its value. Next, we'll click on the write button to enter a new desired position. Look, the arm moves. That's excellent. Now go back and try the same thing with the second characteristic, which will move motor 2. Now we can move the robot remotely from a BLE connected phone. In the next videos, I'm going to show you how to program a second PSoC 6 BLE Pioneer Kit to be a central device. It will then be able to act as a remote control for the robot instead of using a phone. You can post your comments and your questions in our PSoC 6 community. Or as always, you're welcome to email me at alan_hawse@cypress.com or tweet me at AskIoTExpert. Thank you very much.